Yes, sir.
Hello.
Yes, sir.
Okay. Okay. My voice is audible to all of you?
Yes, sir.
Yeah. So
Yes,
good
sir.
evening
Yes,
to
sir.
all of you. Okay. And you know that today is my for this workshop. Today is the last day. So today, first we start with some probability distribution, because for any data science, data analysis, better to say, we need the probability as well as the distribution. So and this distribution divided into two parts. That is, one is the discrete distribution, another is the continuous distribution. So I will give some flavor, not in detail because time is a parameter. So I will give some briefly concept about what is the discrete distribution, definitely using Python code, and some distribution about the continuous distribution, mainly the normal, exponential, and beta. And then I'll jump to, again, I'm telling you not in detail, briefly I'll give because time is a barrier. And then I'll jump to the testing of hypothesis, which is very important.
Sir, nothing is audible.
We
Hello, sir.
cannot hear.
Hello, my voice is audible now. Sorry, actually,
Yes, sir.
in Behala, load shedding, and
Oh,
suddenly. Okay,
acha, acha, acha.
just okay, sorry.
Okay, audible now.
Okay, audible. Thank you. So
Sir,
today,
can you speak a little louder, sir?
okay. Now it is okay. Hello.
Sir,
Yes, sir.
Yes, sir. Absolutely
you
okay.
can speak a little louder, sir.
Yes, sir.
Okay. Sharing is not turned on. Hello.
স্যার এবার দেখুন তো
Now it is coming.
আবার চলে যাওয়ার জন্য বোধহয় ইয়ে হচ্ছিল।
Uh-huh.
Yes, sir. Your screen is visible.
Okay. So that's why today we'll start with some discrete distribution, and then we'll start about some continuous distribution, because this is the very important, because we have to know that from where the theoretical distribution like normal distribution, binomial distribution, Poisson distribution, and like the hypergeometric distribution is created. Okay. And on the basis of this, we can start the sampling distribution, like the T, F, and chi-square. So first we start with some discrete distribution with some example. So this is about, I hope it is visible to all of you. Hello.
Yes, visible.
So first of all, you have to know when either discrete or continuous, there are two things. For any distribution, there is a theoretical form. What is the theoretical form? Theoretical form developed on the basis of total population. But when we solve some problem, any problem of statistics, machine learning, so we have to based on sample. And in some cases, the sample size is very small. And when the sample size is very small, but we know the pattern of the sample, say, follows binomial, say, pattern follows Poisson, say, pattern follows hypergeometry, pattern follows normal, then what we can do, we can generate the number of more sample on the basis of simulation using random number technique. Okay. So this is the very simple way, and maximum case, we are doing this concept in the machine learning as well as the deep learning. Okay. So now first what is the first we discuss about the Bernoulli distribution. And this is basically, the documentation of Bernoulli distribution. I hope, since I will give my PPT after my lectures, so I will be little bit fast because I have to cover so many things. So here, factory produces electronic components. Each component produced is independently tested to determine
Sir, your PPT is not visible.
if it is visible.
No, it's visible. It's visible.
Visible?
Yes.
Yes, sir.
Right? Then why I am missing it? Okay,
Right.
okay. See. Then sir,
I
continue, sir.
hope it is visible. Hello.
Yes, sir. Visible, sir.
So just before starting any distribution, first you have to tell the story. This is basically a story of Bernoulli distribution. The story is nothing but the probability that a component is defective, suppose, is the 0.30% chance that a component is defective. And we consider here P is the success. And because binomial means there is one is a success, another is the failure, simply try to understand the A plus B whole square. This is the binomial theorem. A plus B whole cube, binomial theorem. So there are two terms, A and B. So that means A may be considered as success, B considered as failure. Okay. And what is the meaning of power? Power means the number of trials. So that means A plus B whole square means, say, a coin is tossed 2 times. A plus B whole cube means a coin is tossed 3 times. So that means if a coin is tossed n times, so that is A plus B whole to the power n. So that is basically a binomial theorem. Okay. And from binomial theorem, using probability, we can apply the binomial distribution. Now, why I'm telling the story, this is very important because story for any distribution, like continuous, like discrete, started from a discrete distribution, and the name of the discrete distribution is the hypergeometric distribution, hypergeometric distribution. And that is the first phase of the probability distribution. Because using hypergeometric distribution, we can estimate some unknown. So I am telling a very interesting story, then you can understand why the distribution is important. Suppose in a pond, there are say, hypothetically, there are say 12,000 fishes. Hypothetically. But I don't know that. I don't know that there are 12,000 fishes. So apply some probability concept. Use that probability concept and using some mathematical relation that is called the recurrence relation, we can estimate using some trials, number of times, we can estimate the number of fishes. And there are so many experiments going on, and using so many experiments, estimated that if there are 12,000 fishes, we can get 11,600 fishes using sampling distribution, using taking the samples. So there is say 2 or 3% error. So what is our objective? How to minimize the error. So that is the main starting of the probability distribution, that is called the hypergeometric distribution. And basically hypergeometric distribution we are solving every day in case of probability class. For a box containing some red ball, black balls, we are drawing some balls, and what is the probability of getting this red, this bad. And this is basically a hypergeometric problem. And when we apply these and form using some criteria, that is called the limiting condition, on hypergeometric distribution, we can derive the binomial distribution. This is also the discrete. And from binomial distribution, we can derive the Poisson distribution. So what is the difference between binomial and Poisson? Binomial is the countable finite distribution. Is it discrete? Countable finite. And Poisson is the countable infinite distribution. So you can ask me, sir, why this is important? Because if we don't know hypergeometric, we don't know the binomial. We don't know Poisson. And nowadays we are using normal for any kind of parametric method. That is also derived from the binomial distribution. So normal distribution also is the limiting condition of the binomial distribution. Okay. So with this, for this example, I'm using the Bernoulli trials. So simulate, there are the total 1,000 components. Simulate the products. Simulate means randomly we have selected as the independent Bernoulli trials. Then we have to compute the sample mean and sample variance of the results. So compare the sample statistics to the theoretical mean and variance of the Bernoulli distribution and visualize the distribution of defective and non-defective components with a bar. So this is my question. So then we apply Python. So for Python, we have to import the NumPy, some library as NP. And for the drawing the graph or visualization, we are import the matplotlib.pyplot as PLT. And since we apply some statistics, mean, standard deviation, so from scipy.stats, import Bernoulli. So Bernoulli as a module in the scipy.stats. And then what is that? Every time you give the documentation. So what is my problem parameters? Problem parameters is P is the probability of success, which is given 0.3, and N trials 1,000 because number of components tested. This is my first step. What is the first step? Is the import the library. Second step is the problem parameters. Third step is the simulate the Bernoulli trials. How we can simulate? Using the random variable concept. So Bernoulli, because already I import the Bernoulli. So for Bernoulli, using the Bernoulli, we apply the simulation of random variables. P means the probability of success. Size, that is the number of trials. So this is called the simulation technique. Now, the theoretical values. Theoretical values means which you get from the, from the probability mass function of the Bernoulli trials. So you can easily get the mean theoretical, Bernoulli mean, and Bernoulli variance. And then this is called theoretical values. And then this is the sample statistics. Sample statistics means which we calculate on the basis of sample values. Here the sample is the 1000. And then we calculate mean sample and variance sample. So after these, we compute the some results. That is the print results. So print results, we calculate the theoretical mean, we calculate the sample mean, we calculate the theoretical variance, we calculate the sample variance. And after printing this result, we go for plotting. So this is my total thing we have drawn in a simple, after giving the documentation, we have written. Step by step after giving the documentation. So now we like to run this. It will take time because so many things I have written in a, yeah, that means this is the correct. And when you get this correct, we get this out. So what is the output? Theoretical value is 0.3, that we already given. Sample mean, that is, we calculated on the basis of 1000 observations, just to think it is near to 0.3 because the 1000 samples drawn on the Bernoulli trials. And theoretical value for the Bernoulli trials is P into 1 minus P, that is 0.21, that is the theoretical values, variance. And sample variance, definitely we get the P value in P into 1 minus, which is also near to 0.2. And this is my Bernoulli distribution. This is the defective distribution, and this is the weird comparable. Now I'm coming to the binomial distribution. So binomial distribution in a factory, again, same problem. But here we have taken only the batch of 20 components is tested. And simulate the number of defective components in each batch over the 1000 batches. Compute the sample mean and sample variance. And we know the sample mean for the theoretical mean is NP. So N is the number of trials and P is the probability of success. And theoretical variance is called NPQ. NPQ, okay. So now on the basis of these 1000 batches, we compute the sample mean and sample variance of the number of defectives across the batches. And compute this with the theoretical mean and variance of the binomial distribution. And then plot the histogram showing the distribution of the defect counts in the batches. So this is my problem. The same thing, we import numpy as NP, import matplotlib.pyplot as PLT, and from scipy dots as import binom. So this is my module binom. So definitely when you create the simulation technique, we have to create the random, we have to simulate from the binom module. So and this is my, what is the parameter? N equal to 20, P equal to 0.3. This is my parameter. And what is the N batches? How many batches? 1000, that is the number of batches. That means from each batch, we are considering 20 samples. And simulate 1000 binomial trials. So this is same, we are using binom.random variables. N, that is the number of components. P is the probability of success or probability of defect. And size is equal to N batches. N batches where N equal to 1000. And this is my total samples because we have to generate these samples. Okay. And this is this next we go for theoretical mean and variance. Same thing. Theoretical mean is N and P, binomial mean that we know there is the mean is the N into P. And theoretical variance is NPQ. Just we calculate binom.var. Then we calculate sample mean and variance. mean sample NP dot mean samples, variance sample NP dot variance samples. Why? Because these all, why it is samples? Because these all random variables are saved into samples. So obviously, we calculate variance from samples. Okay. And now what are the results we'll get? We get the results. We get the theoretical mean. We get the sample mean. And we get the theoretical variance in NPQ. And we get the sample variance. Okay. Already I told you that is the theoretical variance is NPQ. And we are calculating sample variance simply using the variance formula. And we will show what is our objective to show it is approximately equal to the theoretical variance NPQ. Similarly, in case of sample mean also. And then the plot histogram. So just to think, when you get this, so we run this. After running, we get these results. That theoretical mean is 6. Why? Because 20 into 0.3. But the sample mean is 5.933, which is equal to 6. Because these samples drawn from the binomial. So I'm telling you, nowadays in the deep learning, the very interesting topic is the how to recognize the pattern. So how to recognize the pattern for the pattern recognition? So they first get some sample. And after getting the sample, apply the simulation technique. Apply the random number simulation technique on the basis of that sample. And definitely if we know that the samples drawn from binomial, samples drawn from Poisson, maybe samples drawn from normal, so they apply the simulation of that distribution. Okay, and right then we get the, because we know if it is normal distribution, so we know the theoretical mean. If it is the binomial distribution, we know the theoretical mean. So on the basis of random number sample, simulated sample, we try to equate that it is equal or not. That means our samples drawn from normal distribution. So this process is applicable for any kind of pattern recognition. Okay. So now, so this is we get NPQ is getting 4.2. That is the theoretical variance. Sample variance is 4.3 and near to that. And this is the histogram of binomial distribution. And if you think why I have shown this, because I have drawn with the drawn is n equal to 20. And if n is more large, so there is a very interesting concept why I have drawn this. Because the condition of normal distribution is that when n is very large and the probability of success is very less. And definitely we know the mean of the binomial distribution is NP. And if this the product n and p greater than 7 or some textbook is written 8 also, greater than 7 or 8, then it follows the normal distribution. This is the criteria limiting condition of binomial to normal. So you can ask me, sir, what will happen if the NP less than 6 or less than 7? Then that is the condition binomial tends to Poisson distribution. Because n is very large means countable infinite. We can count but not finished. So that is the condition for binomial to Poisson and binomial to normal. So this is my objective why I'm showing binomial distribution. And finally, I have drawn Poisson distribution. I'm not going in detail. Same thing, that Poisson distribution, it is say, what are the examples? Because I'm telling you, so at the beginning of the today's class, so we are asking which type of course we prefer. We are discussing. So not my suggestion. So I think, so there are 3 letters for any kind of course is very important. That is the WWH. What is the WWH? W is what is this? Then second W is why. That is the application. And now the last is H. That is the how. So now this course we are doing only the how part, H part. And that is the real problem for this course. Because if we don't know the first W and second W, then there is no use of Python, any software. Am I wrong or right? Hello? Hello, my voice is audible?
Yeah, yeah, audible. I'm
Yes,
very
sir.
much
Yes, sir.
Yes, sir.
without knowing
So, I'm
statistics, if
telling
we
you, you
apply
can.
manual,
So,
mechanically,
hello?
there's no meaning
Huh?
actually.
Huh?
Without knowing statistics, if we apply it mechanically, so there's no meaning. You're correct, very
Yeah,
much correct.
right. That is my objective. When you suppose if you conduct any 7 days course, so that course to be designed like this way, any course designed like this way. What is this? Why this? Then how this? So then any kind of course is the fruitful. This is my, not suggestion. I am thinking like this way. So that's why I have given this concept, because if we start the probability, I'm telling you, when you solve regression, so many things, we are getting the p-value. And our hypothesis, any kind of testing of hypothesis based on p-value, either we reject the hypothesis or accept that. But we don't know the probability. But we don't know the thumb rule. If the p greater than 0.05, that is the p-value, we accept null hypothesis. Okay, but my question is, if we know the probability, if we know the distribution, if we know the random variable concept, if we know the sampling, if we know the estimation part, then we can understand when a parameter will be the unbiased or biased. Okay, and then we can easily understand testing of hypothesis. So this is example of Poisson distribution. I'll not much more time. I will give my PPT, and it's my request to all of you. I know everyone knows the Poisson distribution. So in the same way, I am deriving the Poisson distribution. What is the parameters in Poisson? What is the sample simulation of Poisson? Again, simulation of Poisson distribution. And again, the theoretical mean of the Poisson sample mean same way distribute, same way we derive the Poisson distribution, because we know the theoretical mean of Poisson distribution is the lambda. So here lambda equal to 4. And on the basis of sample, we get 3.948, which is near to the 4. And theoretical, and this is a very interesting distribution. The mean and variance are same. Mean and variance are same. And that's why mean is 4, variance is 4. And sample variance is near to 4. Okay. So this is I'm discussing only the two property, that is the mean variance. There are so many property of binomial distribution like skewness, kurtosis, recurrence relation. Similarly, so many property of Poisson distribution. So I'm not going in detail. Next, I have discussed geometric distribution. Story is given. I'll give my PPT, and then I'll give the hypergeometric distribution. And finally, ended my discrete distribution is the negative binomial distribution. Actually, these are basically the very, very important and discrete distribution. So when you work on, mainly if you ask me that, what are the application of this discrete distribution? Mainly in case of stock market data, option derivative, we are using this discrete distribution. Okay. And in so many places, you are using the discrete distribution. So I'm going to now my continuous distribution part. So continuous distribution is starting. This is my favorite distribution. And everyone knows this is the parent distribution of the data science. So this is the normal distribution. And we mainly all researcher, we are saying for when you get the data, we are trying to prove it follows the normal distribution. Question is why? Because maximum assumptions of our statistical method based on normal distribution. Okay, and if it disobeys, if it is failed, so definitely we have to shift to the other method. And that's why we are using smart PLS. There is no assumption needed. So that's why we go for the big data. No assumption needed. Okay. So when you shift to the logistic regression, we need the no assumption of normality. When you shift to the discriminant analysis, since this is basically it is based for the small sample, we apply the normal distribution assumption. So there are so many things. So I'm telling that is the length of rods produced by a factory follow a normal distribution with a mean of 100 centimeter length of rod and standard deviation of 10 centimeter. So definitely these are called theoretical values. So this is the theoretical mean is 100 centimeter and theoretical standard deviation is 10 centimeter. And we want to know that model the rod length using a normal distribution. Simulate the 1000 rod length in this way. This is the experimental data. So easily you can simulate the 1000 rod lengths from this distribution, compute the sample mean and the sample standard deviation, and compare this with the theoretical mean and the same process, and plotting histogram of the simulated rod length and the normal probability distribution because it is the continuous. That's why it is called probability density function. Okay. So same import NumPy as in import matplotlib plot by plot this from SciPy. And first, what is my step? What are the parameters? Here mu equal to 100 theoretical parameters, sigma equal to 10, and n samples equal to 1000. So these are called parameters documentation. And then what is the generate samples? So how we can generate sample? Already I told you that from the simulation random variable. And that's why SciPy.stats we import the NOR normal distribution. Norm. So for then how we generate samples? Norm.random variables, location means mean, and scale means sigma. Okay. So there are 4 terms are very important in statistics. 4 terms. One is the location, that is called first order. Second is the scale, that is the second order. Third is the shape, third order. And finally pickedness. So location, mainly the mean. Scale means standard deviation. Shape means skewness. Pickedness means kurtosis. So these are 4 words are very important. Location, scale, shape, and pickedness. So location, scale, and size is the samples. So this is how we generate the samples. And how many samples we have drawing? We already have given n underscore samples equal to 1000. So that means we are drawing 1000 samples. And on the basis of this, we calculate the sample statistics. The sample statistics mean we calculate mean of sample and standard deviation of sample. Then we calculate the theoretical values. What are the theoretical values? Mu and sigma. And same as print this. Theoretical mean, sample mean, theoretical standard deviation, and we plot the histogram. So we get theoretical mean, so we run this. We run this. So naturally, after running, we get this result that theoretical mean is 100. Sample means just to check near to 100. And theoretical standard deviation equal to 10 and sample standard deviation equal to 3. So from this result, we get one analysis we can derive. If I simulate less number of sample, that is instead of 1000, if we take only 100 samples, so definitely there is a difference between theoretical mean and sample. So what does it prove? If the sample size is more and more, it is near to the population mean. Okay. And that is the sample mean is near to the population mean. Why I have shown it? Because now, after this, we will go for the testing of hypothesis. So what is the testing of hypothesis? Now, with the help of testing of hypothesis, we like to test the population parameter on the basis of statistics. So that is our objective, how to test the population parameter on the basis of sample statistics. What is the meaning of it? That means we can test population mean with the help of sample mean. We can test population standard deviation with the help of sample standard deviation. This is for the univariate data. Similarly, for the bivariate, we can test population correlation with the help of sample correlation. We can test population regression coefficient with the help of sample regression coefficient. There are so many things. And in this way, when you go to the multivariate, so we can test the multivariate parameter with the help of sample statistics. Okay. So now I'm coming to the diagram, and if you check the diagram, it looks like a normal distribution. But if the sample size is less and there is a huge difference between the theoretical mean and sample mean, automatically the diagram will not follow the normal distribution. So with this, there are so many distribution is covered, exponential I have given, but I am not showing because no time, because when everyone since knows the normal distribution, that's why I have shown normal distribution, because my next part basically based on normal distribution. Any question? Hello. Can I go to my next part?
Yes, sir.
Okay. So now I'm going to the very, very interesting part of t-test. Mainly, I have covered with a very simple example, that is t-test. There are so many types of t-test, but I have covered only a single test, the chi-square test and f-test. So, I'm telling a very interesting story that mainly we know that T is derived from normal distribution, and T basically a sampling distribution first. And T sampling, what is the meaning of sampling distribution? Now, when a distribution is derived from some theoretical distribution. So, what is theoretical distribution? Because normal distribution already have shown theoretical distribution. And T basically derived from normal and chi-square. Very fine. And chi-square also derived from normal distribution. So, and T mainly used for small sample size. Okay. That means when the sample size is small. But there are so many examples, very nice example, that in SPSS there is a file. Actually, nowadays there is a very there is not the free software. There is one software. The backend is Python. They are using their example and taking from SPSS. Okay. And there are one case study in SPSS. So you will be astonished. The example is like this. There are two populations and containing, first population containing 250 samples, second population also containing 250 samples. So obviously, total number of samples is 500. And just that means sample size is very large. But the problem is, in the SPSS tutorial, they are using t-test. So then I thought, why the sample size is more, but SPSS tutorial using the normal t-distribution. The question is, there is a very interesting thing. You know the sample size, but if you don't know what is your population variance. Because again, I'm telling you, there are two things. One is the population variance, and another is the sample variance. But your sample size are known, but you don't know the population variance. So what does it mean? So when the sample size are known, so on the basis of sample, easily you can calculate the sample variance. Okay. And then they applied t-distribution. Then I thought that how we calculate the test of statistics. Because test of statistics has given the t-test for the 498 degrees of freedom. Why 498? N1 plus N2 minus 2. And if you check the t table, the 498 degrees of freedom is present at the 5% level of freedom. And SPSS solved. Okay. And if you can check, you can easily check that. I can share that file also, where the total number of samples is 500. So basically, but here I am saying small sample, small sample. I think that is not the right word according to my perception. Mainly small sample means basically from where we can easily calculate the sample variance. Okay. And definitely when the population variance is not known. So the inspector wants to check, is the average length of the rod significantly different from 100 centimeters? So this is my hypothesis. So this is my null hypothesis, that H0 population mean equal to 100 versus population mean not equal to 100. So then what is my sample size? 25. So easily we can compute sample mean. We can easily compute sample standard deviation. Easily you can compute the t statistics. And easily we compute the p-value. Then we can decide if the result is statistically significant at 5% level of significance. And then easily you can plot. And the t-distribution curve for degrees of freedom 24, because this is the one population test, it follows a n-1 degrees of n-1 and make the calculated statistics on that. So this is the simple problem of these statistics. And definitely on one population. In this way, we can compute the three statistics for the two population, independent population. We can compute these statistics for the paired population. In this way, you can so many tests. Not only that, T basically used for population correlation test. T statistics used for the regression coefficient test. There are so many applications of T statistics. So we try to write that again import numpy as np, same thing, and obviously we need now the t-test module for one sample. Similarly, when you go for two tests, two population, you import the two sample tests. So here I am taken true mean equal to 98. And sigma is equal to 10, sigma equal to 10, and mu under null hypothesis equal to 100, and n equal to 25. There is a sample size, and alpha equal to 5%. So definitely these are the parameters. These are the parameters. And this is, we have to generate a sample. And using again the random number seed concept. So that is that we are computing a random number from normal distribution because T is derived from normal distribution. A location, that is the mean, true mean, and scale sigma already I defined, and size equal to n. So that means we get the generate our 25 samples. And after generating 25 samples, we go for sample mean and sample standard deviation, and then compute T statistics. What is the statistics value? X bar minus mu divided by standard error. So what is standard error? The sample standard deviation by square root of n. That is the standard error. So this is my T statistics formula. So manually, in case of Python, we can easily compute. Because from this command, we can calculate sample mean, and mu theta is given 100, and the sample standard deviation is, we can easily calculate, and n square root n easily calculate. So easily you can calculate the T statistic. Question is why this is important. I'm trying to get using some Python results, and then Python result I can manually check. So this is called as, to some extent, manual checking using the formula, and compute p-value. And we know that this is the computational p-value, and that is the two-sided tail, degrees of freedom n-1. and we get the different results, same as before. And what type of decision? If p-value is less than alpha, that is the reject H0. Okay, and otherwise else we have to fail to reject H0. So that is the decision criteria. And plot the t distribution. And if we can plot the t distribution, so I'm running this. Okay, so after getting this, so this is my sample mean, this is my sample standard deviation, this is my t statistics value, and this is my p value. So definitely this t statistics value is 1.25. That is the fail to reject H0. That is no significant difference from 100, because here H0 is accepted. Fail to reject H0, because here t statistics value is 1.25. And there is p value equal to 0.2, and already I told you that if the p value is more than 0.05, obviously no question to reject H0. Okay. And this is our diagram. It looks like a normal distribution, and this is we have drawn the t distribution, the 24 degrees of freedom. Here the t statistics value near to 1.26. That is my calculated value. That is my calculated value. And that is my rejection region. So definitely this is my dotted red lines. This is my calculated value of t. And obviously t starting from also minus infinity to plus infinity. But in most of the graph, we try to show the 4 sigma level. That's why -4 to +4 is mentioned. Okay. So then now I am coming quickly the concept of F statistics. Mainly, there is very interesting. F basically used for two population variants, and the F is called global test statistics. So if we run t-test in SPSS, you can check it that when the t-test outputs are coming, then you get the t statistics values, degrees of freedom, p-value, and their confidence intervals. So many things will be coming, standard error will be coming. And in the left side, first the F statistics will be coming. Question is why? Because when we are testing two population mean, two independent population mean, then the F must come. Why must come? Because F will check first their two population variants are same or not. And if the two population variants are same, so then definitely the t-test will be accepted. Here H0 will be accepted, but the reverse is not true. Maybe in some cases, T is accepted, but F is rejected. Okay. So this is a very interesting thing. And that's why if you follow SPSS, in case of that, first, in case of any two population independent t-test, F is given. Why? Because F testing the two population variants. So a factory runs two machines production lots. That is the two population. Machine A rod length have variance 25 centimeters. Machine B's rod length have 16 centimeters. And we want to check that are the variance of the two machines significantly different. So definitely, well, simulate samples. How many samples? Machine A, we have taken the 20 values, rods. Machine B, 15 rods, N1, N2. And what is the F test? Equality of variance, that is my H0, sigma 1 square equal to sigma 2 square. And compute F statistics, p value, compute alpha equal to 5% level, plot, then F distribution PDF with the calculated F statistics. So this is my, the documentation of F statistics. So again we go for, that means same as this, but we scipy.stats, we have to import F. And what is my parameters? that is the sigma 1 equal to 5 because we have taken variance 25. So that is the standard deviation for machine A. Sigma 2, that is 4 for 16 is given. So that is the standard deviation for machine B. N1 is the 20, N2 is the 15, and definitely alpha is the 5% level of Z. And first is the parameter. Then simulate samples. How we can simulate? Again using the random number. Random number simulation. There is a sample 1, okay, N1, sample 2, N2. Why? Because N1 is 20, so we have to simulate 20 samples from population 1. That is sample 1 and sample 2. And definitely F follows, F is basically ratio of 2 chi-square, and chi-square also derived from normal, and that's why we're drawing the sample from the normal distribution. It's a very interesting. Okay. And sample variance, we calculate sample variance. And sample variance for two variance, we have to calculate S1 square and S2 square. And then easily we can compute the F statistics, the variance 1 by variance 2. And since it is based on sample values, so that p-value 2 degrees of, when you, I'm telling you, when you run ANOVA table, okay, when you run regression table, we get the F statistics. And for that F statistics, there are 2 degrees of freedom. One is the N1, N2. So N1, N2, the 2 degrees of freedom. Sometimes it's N1 minus 1, N2 minus 1. But in case of a regression analysis, the degrees of freedom for the model is, just try to remember, that is equal to K minus 1. And regression, degrees of freedom for the residual is the N minus K minus 1. So this is, and that is follows the F statistics. And that is compute p-value, degrees of freedom is this, N1 minus 1, N2 minus 1. And that part we calculate the lower part and upper part. This is very interesting. Why I am calculating lower and upper? Because if starting from 0 to infinity, it is the ratio of 2 chi-square, it can never be negative. Okay. And the pin results, again, same thing. And we check the p-value for taking the decision. Okay, taking the decision, either we reject H1 or accept H1, and plotting the F statistics value. So we run this. We run this. After running, we get so many values. We get sample variance, that is on the 20 observations. Sample variance, I think initially it is most probably 20 or 25. Sample variance 2, this is my F statistics value. That is my p-value. And definitely p-value is more than 0.05. So fail to reject H0. That means there are 2 population variance are same. And I'm telling you, when you go for 2 population independent t-test, first you go for 2 population variance using F-test. And if it is satisfied, then you are sure about it that your T will be accepted. So this is the graph of that. Always it is the starting from 0. Already I told you. And that is my F statistics. Degrees of freedom in 19 and 14 because N1 minus 1, N2 minus 1. And this is my F statistics value. And this is my rejection region. Okay, this is my rejection region because your F statistics value is 0.67, 0.67, and that is my rejection region. Okay. So again, finally, I'm going to the chi-square test. This is very interesting because chi-square mainly applicable for, there are so many tests we can solve using chi-square. And what is the importance of chi-square? That it can be used for one population variance test. One population variance test, we apply chi-square. We can use for the different proportion test. And there is a very interesting test in our biology class, that is the Mendel's experiment. I'll not tell the story. And there are 4 proportions, P1, P2, P3, P4. and that it can be tested that H0 is accepted or not. And that I'm telling you before chi-square. So we have two types of frequency. One frequency which we are observing, and one frequency which are expected. So I'm telling a story before starting this. Say a coin is tossed, then you can understand what is sample and what is population. A coin is tossed 100 times, say, and you check that out of 100 times, 60 are head and 40 are tail. So this is our sample results. You can repeat, a coin is tossed 100 times, and after repeating the 100 times, we check that the 60 times head and 40 times tail. Very nice. But initially, we thought that we checked that we already told that coin is unbiased. When the coin is unbiased, so obviously the probability of head is equal to probability of tail. Then what is the expected? What will be the expected? The number of head must be equal to the number of tail. The observed frequencies are 60-40, and what is the expected frequency will be 50-50. So on the basis of this, we have designed this problem that a factory produces screws in the four different sizes. What are the sizes? Small, medium, large, extra large. So these are the different sizes. So the factory claims the screws are produced in the following proportion. Small 25%, medium 25%, large 25%, and extra large 25%. So all are same. A quality inspector takes a sample of 200 screws and observe that small prepared 60, medium 50, large 40, and extra large 50. But the factory claims that 25% small produced, 25% medium produced, large and extra, all are same. But quantity inspector takes a sample of 200 screws sample and observe this is the results. So we want to test that screw sizes follow the claim 25, but that means all proportions will be same. That is small, medium, large, and extra large. And what is the alternative? The screw size do not follow the claim proportion at significance level of. Well, so first we compute expected counts, compute the chi-square statistics, compute the p-value, and decide whether to reject H0. So first of all, what is my null hypothesis? Null hypothesis is that simply P1 equal to P2 equal to P3 equal to P4. That is all proportions are same. That is my null hypothesis. That is the screw sizes follow the claim 25%. And what is the alternative? Differ. The claim proportions not equal. Okay. So same thing. We apply NumPy this, import this library, and so on for import the chi-square. So observed and expected frequency first we have to calculate. How we calculate observed? Because we know the observed value 60 small, 50 medium, 40 large, and 50 extra large. And what is the expected? Already I told. That is, if you divide 200 by 4, we get all 50. That is my expected. And compute chi-square distribution. So what is the compute chi-square distribution? We know the statistic, that is F0 means observed frequency minus Fe expected frequency whole square divided by X. Everyone we knows. That is the NP dot sum we are calculating manually. And observed values are given, expected values are given, so easily we can compute this. And what is the degrees of freedom? The length of observed minus 1, that is the n minus 1 degrees of freedom. And what is the p-value? We are calculating this p-value on the basis of the test statistics. We are calculating the free and definitely with the degrees of freedom. And print results same as before. Decision, same thing. If the p-value is less than alpha, reject, otherwise fail to reject. And plot the chi-square distribution, and definitely this is my thing. Now I like to run this. So after running, we are getting the result. That is the chi-square statistics for degrees of freedom 3, because there are total 4 observed values. And p-value is coming 0.26. That means more than 0.05. So definitely no question of rejection of H naught. And because p-value is more than 0.05, and that is just you think this is my chi-square value, and chi-square lies here, and this is my critical region, and this is my acceptance region. So with this, I like to take 3 to 4 minutes time. And before that, you have any question, you can please ask me. So definitely, I'll be actually for this distribution, you need some more time, I know. Question is today, I have to finish the visualization. So that's why I have taken some less time for this probability distribution, okay, and statistics. So after 3 to 4 minutes, I'll go to my last part of my today's class, which is very, very important. That is the visualization. So if you have any question, then please ask me. Hello. Hello.
Yes, you're audible. You're audible.
Yes.
Audible. Actually, can I take 2 to 3 minutes time? Then I will start my next part, visualization.
Yes, yes. We also need it.
Huh?
We also need it.
So
Okay, you also take, you also take. You also take. Thank you. Okay, it is visible to all of you. Hello?
Yes, sir. Visible, sir.
Okay. Okay. So just I'll take 2 minutes time, then I'll start. Can I start now?
Yes, you are back. You can start.
So now the topic is the visualization. That means when you get any data or you have some database, and that type of data you can. Hello.
Yes, sir. Continue.
Okay. So since I am showing only the visualization part, that's why I have imported only one library, that is the Seaborn. So it's my request to all of you, because this session only based on Python data. So that means easily, if you need, I can give my code in the chat box. Question is why some codes. Suppose import Seaborn as SNS, no need to give in the chatbot, easily you can write. So if you open your Google Colab, then you can understand then what is Python. Okay. It's my request to all of you, please open Google Colab. Can I start now?
Yes, please, sir.
So if you open, so first you write the import Seaborn as SNS. You write. And after writing, you run this. Okay. I hope it is clear to all of you. Hello?
Yes, clear. Go ahead.
Now I'm telling you, from this SNS library, you are loading the data set. The name of the file is, loading the data set is the tips. And this is basically a Python file. And this is also saved into the data frame, tips also the data frame. Same name I'm saving for understanding. You can change the name also, I'm telling you. You can give the name X also. Okay. So that is basically, okay, you can put any variable. So this is my second line. What is the first line? The import the library. And what is the second thing? Now you have to, need the data set. And for some cases, this data set you can import from .csv file. Some data set you can import from SPSS. And similarly, you can use the Python data set. So tips is the Python data set. So just you run this. I'm telling you, there are so many data sets in Python, easily you can search it. There are, suppose if you want to solve some time series visualization, so there is a very interesting data set, flights. Okay, so there are so many data sets. So after this, that means already the data set is loaded. That is, the name is the tips. So after getting the data set, always you need to know what information is in the data set. And information means how many variables, how many columns, and how many rows, and what is their data type. That is called the information of the database. So we like to click this. That is the tips.information, and it has come. So I have to explain this. That is basically class pandas.code.frame data frame. And there are total 244 entries. And definitely starting from 0 to 243, this is the index. And there are total 7 variables. And since this is basically the problem based on some restaurant, and that is not from India dataset, from outside of India. The first variable is the total bill, obviously in the float data type. Tip, that is also float data type. Sex, that is a categorical data type. Smoker, yes or no, categorical data type. How many days in the restaurant open, that is also categorical data type. What is the time for the restaurant open, that is also categorical data type. And what are the size of the, peoples are coming, that is the family size, friend circle size, that is also. Maybe size is the single, maybe more than one. Okay. So that is also integer type because size. So what information we get? So there are total 4 category variable, total 2 float variable, and 1 integer variable. And that is total 7 variable. I hope it is clear to all of you. Everything we know. So first we go to what are their values. At least we can understand. So definitely we go for tips.head. That means we can check the first 5. That's the first 5 records. So total bill, float, tip, definitely tip is less than total float. And definitely tip is depending on total float. Sex is female, smoker no. And the day is the Sunday, time is the dinner time. And their family size is 2. Another record, that is their family size 3, their total BC is 10.34. They're having the tip 1.66 and so on. So this is the information. In this way, we can get the 244 records. And if you want to get the first 10, we get this. Similarly, first 10. Now, we can get the last 5. The last 5. And from this, we can understand the total 244 records. So, up to this, I hope it is clear to all of you. Okay. So now I am going for visualization part. Yesterday, I have shown some visualization in case of regression analysis. Here I will mention, first we start with the distribution plot. And this distribution plot, basically for the univariate data. Univariate data. And definitely, for univariate data distribution means when the univariate data is not the categorical data. So here, 3 types of data or 3 types of variable are not categorical. One is the total bill is not categorical, tip is not categorical, and size is not categorical. So other 4 are categorical data. And so, when we get this, so first we go for the distribution plot. That what is the meaning of distribution plot that we can give, so the histogram. So simple, you give, yesterday I have shown it, that SNS dot distribution plot is plot. This is my database name, tips, data frame. And from this data frame, we consider only the variable total bill, which is the float type. So that's why just to check, we apply the first bracket, that is the tuple, and I have written because this is the total bill under the list, because then I can get the values. Okay. And we just run this. When we run this, we can show the histogram of the total bill, and this is the density of the total bill. But it is not fully the normal distribution. So I am telling you, so when you have given this distribution, then Python, since it's a library, there are so many modules, so many functions. They created the class boundary of the total bill values boundary along the x-axis, and they calculate the frequency density along y-axis, dividing the frequency by the width of the class. So that is that computations they are doing. And after doing, they are plotting this concept. So already I have shown how to plot manually in the probability distribution. But if we apply the SNS, Seaborn library, so they are calculating. If we give the only, that is simple. If we give the only the name of the variable under the data set, and if we apply the function, that is SNS and drop, and basically this is the called argument. And always you try to write the argument either in tuple and the list form. That you have to understand. Why I have given the first bracket and why I have given the third bracket. Okay. So we get the distribution plot of tips. And if you form the distribution, we can check that maximum bill takes the value in between. So their maximum bill spended by the 244 average mainly. That peak is high. Just to check, that peak is high. And that is nearly the average bill. And I'm telling you today, I'm not showing any kind of statistics. Here, what is the description of this? Then you get the 7-point summary, already discussed. So if you want to do this in the same thing, you have to import some NumPy, Pandas, so many libraries. Okay. Only I am working in visualization. So now, after drawing this visualization distribution plot, so since again another float variable is tip, same thing, same command, only changing the variable tip. So simply select. We get the result. So also tip is, maximum tip is given for the lower values. And that's why tip nearly more than 2 point something dollar. Okay, maximum. Maximum and very high tip is less frequency. Very high frequency tip is very less, and maximum tip frequencies for the lower tip. That is given from the diagram. So that is basically tip. Now I can show this is very interesting, that we can change. I like to show only the histogram. Only the histogram, not the curve. Then we can give what is the command, what is the argument. Tips equal to tip. You can give the total bill also. Kernel density false. Kernel density false means there will be no curve. And we can take the beans. Beans mean, the concept of width of the class. Width of the class. We can take this. That is, we are taking distribution plot of tip. Kernel density false. That means this curve will not be coming. And beans equal to 10. And what will be coming? So beans means the range. Okay. So that is without density. That means from this, we can say the tip will not follow the normal distribution. Because no density is given, only from the histogram. It is not a normal distribution set. Okay. So after this, we go for again a total bill. Total bill. And total bill also not following the normal distribution. So I hope the distribution plot is clear. So what is the summarization of distribution plot? The summarization of distribution plot means distribution plot we can apply for a univariate single variable. This is the number one, which is definitely continuous in nature. Distribution plot we can apply for better to say data type is the mainly the float and mainly float. Maybe some for not for the integer variable, no need for the distribution plot. Maybe for the float data type. This is the number one. Number two, distribution plot, we can give the histogram as well as the density. And from distribution plot, we can get the idea that your data is following normal or not. Okay. So this is the about your distribution plot. And if any question you can ask, then I'll go to the next part is the join plot. Hello. Hello.
Yes, you're audible.
Yes, sir.
No
Yes,
question actually. You can
No
go ahead.
question. Thank you. Thank you.
We are doing it along with you.
Okay. Actually, I'm going slowly. That's why.
Yeah. We are able to type properly, so we are able to do it.
Yeah. Thank you. Thank you. So I'm showing the join plot. Join plot means when you consider two variables. When you consider two variables means one is X, another is Y. That means when you draw the join plot, that is basically the bivariate plot. And where we consider X-axis and as well as the Y-axis. And definitely from the domain knowledge, we have to know what is my X and what is my Y. And we are collecting X and Y from my database. That is the name of the data set is the tips. Okay. So we are drawing simply SNS dot join plot. This is my function and what is the argument. And just to think, here argument I have taken in the tuple form because we can never change. Always we apply the tuple form. In the tuple form, we take X equal to total bill and Y equal to tip and data equal to tips. Because we are drawing X and Y from this tips data set. And after this, we just run this. So after running, this is the upper part is the distribution plot of total bill and this is the distribution plot of tip. And this is basically the scatter diagram of 244 observations between tip, total bill and tip. So what is the meaning of join plot? Join plot gives distribution plot of univariate and scatter plot of bivariate. And that's why it is called join plot. Okay. So after this, again we can consider that to understand, this observation is very small in size. So we can plot same thing, changing the size of the observation. And size kind equal to, we are taking the hexagon. Hexagon, that is the 6 spaces. Same thing. You can simply copy and put it, okay, and just changing the kind. Mainly we are changing the arguments and automatically your graph pattern will change. So you can use so many colors, so many things we can use in the graph. So now we can run this. And this is just to think, these are the observations. And from this observation, maximum cluster in the lower range. And there are some values at the higher range, and that we can say this is the outlier of the total bill and tips. Some customers are giving whose the total bill is maximum, they are giving the maximum tip, and their frequency is very less. And from this, it is very much clear that this is maximum data concentrated here. That is the less total bill, less tip. So that command is called kind equal to hex. Okay. So after this, again we go for, this is very interesting. We go for the join plot. And we are taking x equal to total bill, y equal to tip, data equal to tips, but kind equal to regression. So from the visualization part, graph part, we can check the regression line also. So just is selected. And we get this. That means we are getting a distribution plot with density. Distribution plot. This is the distribution plot of total bill. This is the distribution plot of tip. And these are the 244 observations. And this is my regression line. This is so from visualization, we understand that maximum observations are above the line and so many observations below the line. So automatically, the R square will be very less. If you solve this type of problem using the regression, yesterday I have taken the class. Okay. So this is the concept of join plot. Next, and very interesting. So if you change the kind, instead of regression, you are using the kernel density. So you can ask me, sir, why this kernel density function is used? Mainly, from kernel density, we can understand the pattern of the data if it follows the non-linearity. So here, the pattern of the data is not at all a linear data. And that's why regression results are not coming good. Because this is a linear regression. But when you change the pattern by the KD instead of regression, then what do we get there? Very interesting results. We get that this is called kernel density equation. So from the kernel density equation, we can understand that the concentration is at the middle. That is total 240 observations we can draw like this way. So definitely this shape is not a linear shape. It looks like a kernel shape. Okay. So, and this actually, you understand kernel, or I hope maybe you know. So when you go for the, non-parametric regression, then this type of, sorry, just a minute. Yeah. And then you can show that in case of this is a kernel equation, you can show it. Okay. So now I'm coming to, so from this is my join plot. So I have covered the distribution plot and join plot. And definitely all plot based on, your continuous variable. After this, I will show another plot which is very important. And that is also based on continuous variable. And that is called the pair plot. So for the pair plot, very interesting, if you mainly it occurs among the continuous variables. So initially when you start the problem, there are 3 continuous variables and 4 categorical variables. And that part you understand when you go for the pair plot, that how many continuous variables. Because if you give the simple command that SNS dot pair plot tips, and if you run this, so we get a 3 by 3. 3 by 3. Because total bill is a float variable, that is a scale variable, tip is a scale variable, and size is a scale. Out of this, total bill and tip are float type, data type, and size is the integer data type. And that's why graph pattern is changed. Okay. Graph pattern is changed because they are taking the integer value. So many customers are 2 size 2. Some are the size 1, single customers. Some are 3 size, family size. 4 size. Okay, these are the 5 size and the 6 size. So, and the diagonals basically, called the distribution. Diagonal is the distribution plot. And if you check that, the distribution plot for the size simply align. Maximum size 2, their customer size is 2. Maximum. Customer 6 size is very less. Customer 4 and 3 are more or less same. And customer 1 also, single customer is very less. Okay. So this is very interesting. And the diagonals of the distribution, and obviously the off-diagonals are called the scatter diagram, and they are symmetric in nature. Symmetric in nature. And you can check the total bill with the size, and obviously total bill is maximum for the family size 3, then 4. Obviously number is more, total bill is more, and total bill is then, if you can go for rank, so family size 3 is maximum, then 4, then 2, and obviously some size is 6 also. Number of customers are less, but the total bill is more because customers are high. A very interesting phenomena of pair plot. Okay. And definitely when you go for pair plot, we considering full the data set, because if we give the pair plot command, only consider the continuous variable. So no need to give which is one is X, which one is Y. So now I am coming for some concept of pair plot with sex. That means we are mixing now, which is very interesting. We are mixing some continuous variable in the categorical. So selecting SNS pair plot on tips where hue equal to sex. So they segregate the total bill on the basis of sex. That is, there are 2 colors having coming. So there is the blue has the male, and another color is the female. So then from that we can understand that is the male total bills are more compared to the female. So this is the very interesting plot. So if you select this, if we select this, I hope this is coming. So now I'm coming to this same thing, because that means we are considering so many types of pair plot with respect to different categorical variable. First, we have considered sex as a categorical variable. Then we consider another categorical variable, time. That means in which time, because there are time are defined as the lunch time, dinner time. Then which time, this is called the lunch time and dinner time. Which time the bill is more. Which time the tips is more. Which time the family size is more. So that part we can easily determine from this graph. So we select this. So that is coming. So just to check here, the lunch time, maximum dinner time bill is more. Maximum tip is more in the dinner time. Okay. But maximum family size has come in the dinner size. Dinner time. Just to check. Very interesting. Which part the maximum customers are coming. Okay. Now, this is from the graph easily you can determine.
এসছে আর নিচে দরজাটা দেখে তো।
Hello.
Yeah, you continue. There's some sound behind.
So next part is now we are considering how many categorical variable. What is sex? We have shown time Another is, the day. So daytime, just if you see the same thing, pair plot with the daytime. So this is the how many days are the restaurants are open? There are 4 days. There's the Thursday, Friday, Saturday, Sunday. There are 4 days. So from these we can understand where the total bill is maximum, either in Thursday, Friday, Saturday, and Sunday. Where the tips is maximum, where the family size is maximum. Okay, so that we can easily determine from this pair plot with considering some categorical variable. And the last part is for because another categorical variable is smoker. So we are again pair plot with tips with a hue equal to smoker. So this is for the smoker is yes or no. So smoker having 2 category, that from this we understand day is 4 category, 4 levels day, and time is the 2 levels and sex 2 levels. So these are total levels, that is 2 into 2 4, 4 into 4 16, and 16 into 32. So 32 reports we can generate, and definitely this is a very interesting thing. So this is called actually basically the data mining. Okay, and we can solve the data mining tool. That is the 32 reports can be generated, and using that graphically, visually, we are plotting this. Okay. So this is all about the pair plot. Now I am coming to the different colors, palette equal to winter color. The same thing, we are using different color. Okay. And for this today's discussion, the RAC plot is very important, but I'm discarding this. I've discarded. Question is why? Because mainly the RAC plot used for very large sample data, and mainly when you solve any machine learning programming, then we apply the RAC plot. But for this type of data, the RAC plot is not valid. Okay, and it gives the frequency distribution of the data. That part I have discarded. Okay. So this is the very, very important part. That is by box plot, already I discussed. That is the box plot means when you consider the box plot, then we are considering the categorical variable as X, and your continuous variable as Y. And definitely data equal to tips, and the function is same, SNS.box. And we know the sex is the categorical and total bill is the continuous. They're already mentioned. But mainly when you select this, we get this graph. For the male, this is the 5-point summary of total bill. For the female, this is the 5-point summary of the total bill. So what does it mean? That is the maximum total bill spent by the male is more than maximum total bill spent by the female. That part is total clear. And similarly, minimum spend is more than the male minimum values. So this is also clear. Q3 also more than Q3 of female. Median also more than female. And Q1 also more than female. So I'm telling you, when you go for your research, and these some part above the maximum value, some parts above the maximum value. So these are called outlier. That is already I told you that some customers spend high total bills, and their numbers are very less, and that's why they are coming. These are called outlier. Similarly for the females. And easily for your research purpose, you can apply so many things, that how many outliers present, how many observations from your data set lies in maximum and Q3, how many observation lies in Q3 and Q2, and how many observation lies in Q2 and Q1, and how many observation lies in Q1 and minimum. And this part is very, very applicable for any kind of pharmaceutical industry, okay, for any kind of hospital, nursing home. And they are solving their different types of stages of cancer patient using, the blood counting for the different category of the patients, male and female. And not only that, this part is applicable for the stock market data. Question is why in the stock market data, there are huge chance of getting the outliers. Okay. So then if you can find that how many observations are outlier and how many observations lies between, max and Q3, and how many observation lies between Q3 and Q2, and Q2 and Q1 and this. And from this observation, easily we can determine from the basis of past information that which stock and which position of the disease is good or bad. Okay, easily you can determine. In the stock market data, if your maximum number of observations more than Q2, so you can say you can invest it from this year. But similarly, the reverse is true for the blood counting. If it is very, very high report outside the range, so definitely it is not good for the disease. So this is a very, very important part, in the data analysis. That is the box plots. Okay. And again, I'm repeating, box plot mainly occur between the categorical variable as well as the continuous variable. And where the categorical variable will take as a x-axis and continuous variable will take as a y-axis. Okay. And then you can go for so many things, x equal to day, because day is the categorical variable, and total bill. So we know there are 4 days. So from this, you can understand what is the customer's density. Easily you can understand. That means from this, you can understand the maximum total bill spent in the Saturday and Sunday. Easily you can understand. Okay. And definitely the total bill is less in case of Friday and Thursday. So in this way, we can find the day total bill data tips Q equals smoker. This is a very interesting. That means we are considering the 2 categorical variables. Because day is a categorical variable and hue smoker is a categorical variable. Then we are using this, trying to get the box plot. That means we are considering x equal to day, there are 4 days along x-axis, and we are hue considering smokers. Hue means yes or no. So definitely we can show it by the colors. So then if we run this, we can check this tag. Since there are 4 days, for each day, we get there are 2 graphs. One box plot for smoker, one box plot for non-smoker. Similarly, smoker, non-smoker, smoker, non-smoker, smoker, non-smoker. And from there are so many types of these that easily you can show it that how many maximum observations of total bill spent in the higher range. Those who are smokers. So many statistics you can solve from this box. Okay. And finally, we go for the smoker I have completed. Then I go for the bar plot. Bar plot is very simple. Again, in case of bar plot, we consider the categorical variable along x-axis and continuous variable along y-axis. And again, we are taking hue equal to smoker. The same thing. So that means we are getting this. And finally, this is very interesting. We can find x equal to say x, y equal to total bill, and hue equal to day. So that means day-wise, because we have the 4th day, Thursday, Friday, Saturday, Sunday. So definitely Thursday, we can get the total bill bar. Friday for the male, for the Saturday, and for this, similarly for the. And from these, we can easily understand in which day the total bill is more for male as well as female. Easily we can compare. So this is basically a data mining tool And it can be helpful. It will help for your query optimization. Different types of query, between your continuous variable and categorical variable. If you run this, we get this results. Okay. And similarly, we get this only for smoker and sex wise. We can get this. I have drawn so many things actually, so many things. And this is the count plot. Count plot means only we can count. This is very interesting. How many count for this is the Thursday, how many customers. So naturally from this, we can easily count maximum customers in Saturday, that is the more than 8. More than 8. And in Friday, Sunday, that is the near to 80. But in the Friday, it is less than 20 customers. In Thursday, more than 60 customers. So easily you can count how many customers are coming in which day. That is called the count. So, and this is, and using the count plot also, we can go for the categorical variable. We can count that how many smokers are coming for male, non-smokers are coming for female, and same thing. So, okay. And this is also count plot, day wise. And there is a very interesting plot in, mainly this plot is available in R also, and that is called the violin plot. And from violin plot, this looks like a violin. And what is the application of violin plot? Because between the violin, there is a box plot. And for the on the basis of depth of the violin, we can understand where the concentration of data lies maximum. So obviously, if on the basis of constant violin, so total bill is maximum lies here, which is the less than 20. Less than 20. So this is the implication of violin plot. And it is also because from box plot, we don't understand the concentration of the data. And for the concentration of the data, we need the violin plot. And this is same thing for, this is also used for categorical variable. Easily you can check the concentration of the data set. Because there are 4 days and definitely for the male and female. Same thing, I am not repeating. So I think now you are tired because, so I like to stop here. In this way, you can draw so many. I will give this PPT to you. So many graphs, stripper plot. I'm showing what a list of this. And this is another file. So many list. This is the list of this. Okay. This is the list of this. So many things. This is the, this is called, this is very, very important, map has come. Concentration of the data set. This is called heat map. Get this heat map. Okay. And this is a clustering graph will come. Okay. But I'm telling you before visualization, and there is some LM plot, linear model plot, that is a regression plot has also coming. Already I've solved. And similarly, regression plot we can solve from different categorical variable. Regression plot. Also for the total bill categorical variable. And so many things. Okay. So I like to stop here if you have any question. So really, I'm really thankful to you for your patient hearing. Really thanks. Okay. Hello. Hello.
Hello, sir.
Yes, sir.
Sir, this is Shivaji.
You're audible.
Shivaji, tell me.
Yes, sir. Actually, I want to ask that this the data sets that you are showing right now, are these available in Python, and where it is available?
Yeah. Already I told you before starting this visualization part, if you write this command, you get this data set.
Okay. What is the command, sir, for getting the data set?
Already I told you, initially we started with the library. I'm showing. Initially we started with the library and they get the data set. This is the data set.
No, what I'm trying to say is, sir, what are the different data sets which are available freely?
Oh, different data set is available is you have to go to the GitHub library, and there are so many data sets actually, so many data sets.
So from
Uh,
where we can access that? From where
No,
we
no,
can?
no, no, no. I'm telling you, so many data sets, but you have to know, say there are so many time series data set, there are so many ANOVA data set,
Okay.
there are so many regression data set, there are so many PCA data set, okay? There are so many K-means clustering data set, and so everything having the Python data set,
Okay.
everything.
So
So,
there-
okay, then if I get the library, definitely I'll give it.
Okay, sir. Thanks. Thanks, sir.
Definitely. There is a huge list.
Okay, sir.
Because for this visualization, I have used only two data set of Python. One is the tips and flights.
So for that we have to know the name of
And
the
not only that, same thing, I can apply for any data set for my data also.
Okay.
Just to check, in the yesterday, I have solved the regression analysis. I have used my regression data, I have used this. But
Okay.
problem is that in regression, I have no the categorical data, categorical variable.
Okay.
So there is no categorical graph also there, no visualization of categorical. Only I have shown the distribution plot, joint plot, and pair plot.
Okay.
But when mainly the maximum data set, actually, if we solve the ANOVA, I'm telling you, there are all are maximum of the categorical, and some on one or two is the dependent variable on the basis of the one or two ANOVA. Okay.
Okay, sir.
This is the real problem. So that when you go for ANOVA, so there are so many graphs, and in case of categorical variable, most important graph is the bar plot, I'm telling you.
Okay.
So definitely you have to know what is the analysis of bar plot. Because bar plot mainly form for the categorical as well as the summary continuous variable, but categorical variable we consider along the x-axis and summary or continuous variable along the y-axis. That part is very important.
Okay.
And if you go to any industry, they are showing only bar plot. But bar plot means there must be some categorical variable. Okay. But suppose you have some continuous variable, only a single, I can find the bar plot, a box plot, no problem. That
Okay.
means only is giving the box plot of that only one summary variable.
Okay.
Okay, I will try how many huge list of Python files. But
If you can know the source, that will do, sir. Just the source.
it is very difficult. I'm telling you, it's very difficult.
Okay.
You are asking, I don't know what you are doing. I don't know.
Sir, we just want to know the name of the data sets.
I understand your problem. I'm telling you, I have a total SPSS data set of 20 version. I'm telling you.
Okay.
And that maximum data set the Python are using.
Okay.
So I have the SPSS data set, everything.
Okay, sir.
Okay. Now in the version 30, they are changing some data set.
Okay, sir.
That part I have no. So I have data set up to most probably 20 or 22 version. Every data set I have. Because I have collected all data set from the SPSS tutorial.
Okay, sir. That's fine.
I'm telling you. And that SPSS, this value, suppose there is a very interesting data set in Python, that data set using R, that data set using Python, but that data set initially available in SPSS, that is called IRIS data set. I'm telling you.
Okay.
There are another data set is the card that is already available in SPSS, now Python is using.
Okay. What your point, sir?
Is it okay?
Yeah, thank you.
Maximum,
Yeah.
I can give you the list of the everything in SPSS.
Okay,
Everything.
Okay. I want to say
I hope
something
you
here.
understand.
Yeah,
Now,
actually,
they are also using SPSS data. StatCraft is using the SPSS data because SPSS is a huge database.
Understood, sir. Thank you, sir.
yeah. Can I say something here regarding data set?
Yeah, tell me.
Yeah, actually, this data set is required for learning purposes. GB sir is actually explaining the things. That's why he has used it. But whenever we are doing our research, so we will have to use our own data set.
Right.
Class, we have our CSV files. So from there only, we can do our own test. So this data set is required for the trainers because they want to teach something. And for us also, if you want to learn something initially, after that, we have our own data set. So we'll be using that only.
And we can actually, here I have using some Python data. There are so many Python data sets. But I am telling you, we have to understand the database. Nicely tell. So when you deal with your own data, automatically you know your own data, and you form your own data. You know which is my continuous variable and which are my categorical variable, and on the basis according to your objective, easily you can draw. Okay.
Thank you, sir.
So is there any question? Because it is now 9:14. So you are also tired, and today is the last day. So again, I would like to tell you that real thanks to all of you for the 5 days active for your patient here.
Thank you, sir.
Really.
Thank you for this
Thank you
nice
very much.
presentation, sir.
Gautam da.
Sir,
Good
thank you so
evening,
much
sir.
for the wonderful session of continuous 5 days.
From doctor.
Topic was so vast, but your insights and engaging teaching style made us topic easy. Now this is the time for practice. More and more, then only we can understand.
Yeah. And I am telling you, today's lecture I will also give you. After the class, I will send you, and you definitely tomorrow you will get it. And I am telling you, if you practice at least for 2 hours per day, because I know you are engaged in so many colleges, so many universities, so you have no time because so many assignments you have to solve. But at least 1 hour, I'm telling you, at least 1 hour, that is 7 hours in a week. If you give for this practice from my notes, simply you copy the command, then easily you'll understand. And when you face some problem, you go to the book, you can purchase some books, and definitely you can type the command in Google, you get some. So today I'm telling you, today I have given one command. You will be astonished. Today I have given one command that how can I solve the MANOVA in Python? Is it okay? MANOVA. There is the multivariate ANOVA. The multivariate ANOVA is a very not so simple, but I'm telling you, when I have given this command, Python has given so many things, libraries, okay, random samples data, everything. MANOVA is given, Python has given. But problem is, if we don't know MANOVA, then you will not understand. Don't mind the Python out. That is the real problem. So it's my request to all of you. So before doing anything in Python, at least you try to understand what is the theoretical part behind it. Okay. Suppose I am solving, one-way ANOVA. That means we have to know what is one-way ANOVA, what is the hypothesis, what is the application of this, why it is called extension of the t-test, everything. And then what is the how we can test the ANOVA. For ANOVA, we have to calculate. And if you solve a very simple problem, very small problem manually, then you can understand easily the output of Python. It's my opinion, I'm telling, maybe that may not be true. Okay. So just you practice, I'm telling you from my just notes, you'll get so many things. And then you can try on your own concept. Suppose your analysis based on time series, then you go for the time series module using Python. If your objective is the optimization using Python, go for optimization module using Python. If your objective is the MCDM criteria using Python, go for everything having the Python. Is it okay? Suppose you want to go for nowadays the fintech is a very important. So fintech model using Python, go for that. So you search for it, you purchase book on the basis of this, because now you can get the separate books. Okay, there is the foundation books in Python. Okay, some books in libraries. Okay, some books in regression. There are so many things. So many things. Okay.
Thank you, sir. Thank you so much.
Thank you.
Only one promise I'm looking from you, that when you will be appearing again.
Actually, I am telling you, Professor Shantanu, from this workshop, I have learned a lot. This is my opinion.
That always happens for everyone.
I have learned a lot. This is the number one. And from this workshop, I'm telling you that at my age is near to 66. Okay.
That is nominal age only, not mental age.
It is the nominal age. I know, nominal age. But I'm telling you, since all participants are maybe less than 50, less than 40, someone is maybe less than 60. But I'm telling you, if they give time according to their requirement, then definitely they understand Python. And Python is very easy to understand.
So now it is our task to go through all your PPT and do the assignments. And
initially. And then they can go for the chapter wise. chapter wise learning.
Okay.
They suppose some work on based on the testing of hypothesis. So they go for total testing of hypothesis using Python.
So if some query will come up by mail, I will forward it to you, sir.
Definitely.
Actually, I could return only maybe at 8:40.
Okay. So your report is okay.
Huh?
Your report is okay. Doctor
No, not okay, not okay. There is something called CRP, which is very high for me, which is বলছে যে আপনার এই ব্যথাটা কমেছে তাই তা না হলে আমি এখনই আপনাকে হসপিটালে ভর্তি করে দিতাম। CRP is extremely high. So
what is the meaning of CRP actually? I don't understand.
মানে ওটা ইনফেকশনের ইন্ডিকেটর আর কি, মানে ওটা বেশি থাকলে পরে যে কোনো ইনফেকশন বডি নিয়ে নেবে।
ওকে।
এবং যেটা থাকার কথা 5 থেকে 10 সেটা আছে আমার 94. So that is
C-reactive protein, that's an indicator for inflammation.
Yes. I don't know 94 is how much alarming it is, but he expressed it's quite alarming.
Okay.
Now let's carry on with the antibiotics.
So better you need some rest, Shantanu. You need some rest.
That is fine.
I hope you have no class now.
Attend your all the session through live session. So next 2 days I will be going through all your recording, and I will get ready for the same. So many thanks to you, sir.
No,
My regard to you, sir.
Thank you.
Now, if the participants are having anything to mention, anything to share, please come up. স্যার আপনার পেছনে ওটা কিসের সিনারি? একটা বেশ
এটা হচ্ছে সিনারি, হচ্ছে সব ফলগুলো রেখে দিয়েছি।
হ্যাঁ,
সব ফলের সিম্বল।
বেশ,
all are fruits.
Nice. Whether the participants would like to mention anything?
Nothing to mention, just to give thanks to GB sir. This is Anupam here, Anupam Day. So I have got three-way connections with GB sir. One, I am the first PhD student of GB sir.
Okay.
I am also the colleague of GB sir for 16-17 years, more than 16-17 years. And last one, I also member of the music group of GB sir. So three-way connections of GB sir.
I have seen you earlier.
So GB sir is a fantastic teacher, no doubt. He's very popular, and he has got another side of his life. So we have seen him very well. So he's a person with whom if you stay for a few minutes, if you are down, you'll be up again. So if you are down for some reason, something, so you'll get your charge back to you. So that is the GB sir personality. So we're missing GB sir actually. The problem is that we're missing a lot, because that kind of vibes actually. So he is having some positive vibes. Always, whenever he goes, he spreads it. So that part we are missing it.
Yes.
But thank you Gautam da. I never say GB sir. Dada also my guru. So thank you Gautam da, wonderful. আজকে তো আমি সঙ্গে করেছি, যা করেছে টাইপ করে করেছি। খুবই দারুণ হয়েছে, এক্সিলেন্ট। And আমি যা দেখলাম যে তুমি মানে you have given 10 days material in 5 days. That is the thing. Okay, so এত অল্প সময়ে এত তাড়াতাড়ি করে পাইথন শেখানো এবং এত জিনিস শেখানো with statistics, very difficult. But you have done it. Thank you, Gautam. Thank you.
Thank you, Mr. Anupam Dey. Any other observation? Whether anyone?
First of all, thank you, sir, Shantanu sir, for organizing a nice FDP for us, because it is a really vast topic, and for us it was very difficult to understand. But as because of GB sir, we have understood, but we need to practice a lot. And sir, Prosenjit this side, this type of enriching sessions we are looking forward more in near future. Thank you, sir.
Can I know your introduction, Mr. Ghosh?
Myself Prosenjit. I am students of GB sir since 2011. Okay. And right now I am far away from sir, because right now I am at desert, Rajkot.
Feedback form or the feedback link will be given to you by mail, not in this particular chat box. By tonight, the feedback form will be sent to you in a Google form, and that you need to submit by tomorrow.
So do we need to submit at all the feedback?
Yes, yes, yes.
মানে such a session
Feedback is not
and
required for
such a
GB, sir.
renowned professor
No,
like
feedback is not.
আমার তো মনে হয় ফিডব্যাকটা
Probably you are mistaking.
just formality.
Feedback is
Yeah, for certificates, I understand.
Sanjeev, it is only for formality.
and
Yeah.
feedback is about the entire system, and I am also a part of that particular system, and feedback is to collect about your guidelines, your suggestion about the future courses.
Right, right.
So it is not the faculty feedback only, it is feedback of the entire system and your opinion collection. Okay, that is the thing. You please submit your feedback by tomorrow night, and then please give us maybe 7 days time for generation of the certificate, because some signature collection from president and some other formalities are also required for that. So please give us 7 days time for sending the e-copy of the certificates. It will be sent to you by mail also only. And in case of any further suggestion, please come forward by mail and this thing. Okay, Somnath, দেখতে পাচ্ছি তোমাকে fine. So thank you everyone for your active participation, and we all pray to God that God will maintain good health of GB sir, and GB sir
Right,
will
right.
continue taking sessions, and he will be catering to the academic world. Thank you sir, আমার প্রণাম নেবেন।
Thank you.
খুব ভালো,
Thank
many
you, sir.
thanks.
তোমরা ভালো থেকো, সুস্থ থেকো।
Thanks to
Okay, thank you. Thanks everyone.
Okay,
thanks to all.
we are ending the session over
Thank
here.
you, sir. Thank you, sir.
Thank you.
Thank you, sir.
So can I leave now?
Yes sir, you're all leaving. Thank you and good night to all.
Good night.
Good night.